Emanuele, welcome. You will be a speaker for the Python for AI conference that will take place on March 16th in Pavia, hosted by CVision, Python Milan, PyData, as well as ArgoVision. So for that event, in order to prepare for the event, we would like to ask you some questions. So let's get started. Please introduce yourself. Who are you? What do you do? And what topic will you be bringing to the conference?
So I'm head of AI at Extreme, a company that provides solutions for scale-ups and corporates. We build customized AI solutions to solve whatever problem a business may have, from prediction to churn reduction to enhancing operations and so on. The nice thing is that you see always something different, and you work with the best brands in Italy, from Wheel Road to banks to insurance companies to utilities and so on. Myself, I'm a software engineer. Then I did a PhD in artificial intelligence I got a PhD in artificial intelligence from University of Pavia. I was visiting the EPFL in Lausanne during the research, and my research focused on applying machine learning to the energy industry. So at the very beginning, I researched time series forecasting for power load and gas demand forecasting, and then I worked towards finding the topology and the electrical parameters of power networks from measurement at their nodes, which is very relevant for the spreading of microgrids, because our best control algorithms for microgrid require the structure of the network, and nobody really knows where the wires are and what are their electrical parameters. Together with the PhD, I founded Extreme with 4 colleagues. Now we are 20 and still growing.
Oh, thank you very much. So you have a really prolific divulgatory activity. So you do a lot of talks, and especially in the last year or so, since the rise of GPT, you've been talking here and there about anything related to ChatGPT, the key concept to make generative AI possible. So why this change in your career? Are you actually joining and working on generative AI?
So actually about trying to spread the knowledge in science. I've always been trying to since the high school, then in university, and then after that, because I think it's a very relevant. Machine learning and AI are very relevant technologies that everyone nowadays is using without knowing exactly what they are, how they work, and what are their limitations and what is their potential. So actually, this is something that has always been very, very close to my heart. And for Extreme, of course, we are specialized in machine learning on structured data. So we were working with tabular data up until 2023, I would say. We never did computer vision like ArgoVision and CVision. We never did natural language processing because we had to specialize on something, and tabular data is the most widespread in the industry. But in 2023, with the rise of generative AI, customers started to ask us about these kind of solutions, sometimes for very relevant problems, sometimes just because they had to throw the buzzword here and there. And so we needed to follow the market, and we started studying this technology in the same way that as we studied everything else. So starting from the scientific literature and then trying to apply the academic knowledge to the real world.
And this brings you to the topic of your talk. What will we be talking about at the conference?
We'll be talking about diffusion models that are the technology powering DALL-E and Midjourney. It's a fascinating topic because we will follow a journey from 2015 to 2024, trying to understand how a key yet very mysterious concept in physics became the backbone of a very fortunate type of deep learning model.
Sounds very interesting, and in a certain way, the We all know about ChatGPT and generative AI in terms of text, but in fact, generative AI in the field of imagery and images predated that. And actually, some people, when ChatGPT came out, were talking about it as the um, stable diffusion model for text generation. So, why do you think that, or actually, in your opinion, did this text generative AI field became more popular than the imagery one? Are we going to see some inverting trends now that some models are coming up that are displaying science to be much more proficient at generating videos, for example?
In my opinion, we are coming towards a world where text, images, videos, sound all lives in latent spaces, and they're all processed by the same model. uh, Gemini was very clear in indicating this direction, the latest generative AI model from Google, because it's the first truly multimodal model where images, sound, videos, text all contributes to the training of the model, and all is a possible output of the model itself. I think this is most likely the future models that can uh, process any kind of data, and then we will see probably a flourishing of smaller, less expensive, specialized models that will be um, trained for a specific task. So you will have probably GPT-5 completely multimodal, uh, closed access and hidden behind APIs. Gemini 2, same thing. And then you will have Llama for text, Llama for pictures, Llama for videos, and so on. Probably open source, probably less capable than these huge general purpose models, but in I don't know how many months or years time, probably good enough for most tasks. So it's not probably a matter of will text be more popular than pictures, or will image generation be more popular than text, because the next generation of models will treat all this kind of data in the same way. And think about that. It's also a huge potential to harness new data sources, because nowadays large language models are trained on text scraped throughout the internet, but the amount of text that you can scrape is finite, and many high quality sources have already been scraped. And generating new text from people is expensive and slow. While videos, think just about YouTube. Videos are plentiful, and they were not harnessed yet for training these models, because it's much more challenging from an engineering perspective to handle videos than to handle text. So probably that is the next frontier.
Thank you. And still speaking about generative AI, in your experience as head of AI in Extreme, what are some common challenges or misconceptions related to generative AI in particular, but also to the topic of your talk, so stable diffusion and image generation?
The first true challenge is to understand that these technologies are just technologies. They are tools. They are means to reach a purpose, and they should not be treated as something that you have to use because reasons, or something that make an impact by themselves. They don't. Uh, they are useful and impactful only if they are applied to a problem that is suitable for these technologies. So uh, I see many more applications in text processing than in image generation as of now, just because uh, lots of the information we process as people is text. So writing an email, writing a presentation, reading an email, understanding an income statement of a company, and so on and so forth. So there is lots of room for automation there, just because plenty of tasks that up until last year could only be performed by people now can be performed by machines. For image generation, I think that most of the applications are in the field of content creation, because nowadays you can create, edit, and improve pictures without lots of expertise. That is something that up until last year was very difficult. Another interesting point is about, again, multimodal models. That is, up until a couple of years ago, in order to extract some information from images or videos, you needed to train a machine learning model from scratch, or better, to fine tune an open source machine learning model. That was a hard task and was only doable by skilled professionals. Nowadays, you can just prompt a multimodal model and process images. This means that lots of classical computer vision tasks will be democratized and will be accessible to a lot of people that were unaware of these possibilities before. So think about, I don't know, extracting features to price a house, or understanding the location of solar panels from satellite images. Nowadays, it's much easier to do that. So what I see happening is many more applications of this technology will be proposed, just because many more people will be able to use the technology itself. And again, what really makes the difference is the connection of the technology to a problem to be solved. The technology in itself is completely useless. The genius of OpenAI was not only to create great models, but to make the technology accessible. ChatGPT, that has made all the difference, and is probably one of the reasons why this conference will be held, is not an AI model. It's not an AI system. It's just a digital product. It's just a nice interface built upon a large language model. That was just fantastic, because it changed AI from a nice topic in academic and industrial discussions into something that everyone, every person, every human being on Earth is using every day. So again, it's not just about the technology; it's about the ability to match the technology with a business process, or in general a job to be done. And I think this is where, in the next few years, people and companies will make a huge difference and will make or destroy their fortune, because Google. Okay, let's dive into another topic. People say, okay, generative AI is too expensive for normal companies to handle, and it will it will only be a matter of Microsoft versus Google, or Meta versus Microsoft, and so on. True, but that's true for foundational models, that is GPT-4 or Gemini. And that's not the main market. I mean, there will be a handful of foundational model, but there are millions of applications of such models. So where everyone and every company can make a difference is taking the basic technology and applying it to a specific niche, to a specific field where it has expertise, in order to create a new experience, a new product, a new way to solve a problem. It's exactly the same that happened with cloud computing in the early 2010s. A handful of huge companies took the infrastructure, but tens of thousands, hundreds of thousands of other companies built the application upon the infrastructure. Nowadays, we will see exactly the same process unfolding.
Thank you for your thorough answer. Two more questions, and then we'll be closing. The first one is, suppose you're talking to an aspiring data scientist, what recommendation would you give them?
First point is probably learn how to code, because lots of data science and machine learning projects and applications are just software engineering applied in a different field. So the basics of software engineering are very important. I strongly disagree with the CEO of NVIDIA, who's telling the world that we do not need to learn how to code because AI can do that. that's true. AI can code, but AI cannot do software engineering yet. Software engineering is different from coding. It's not only writing a series of statements that does something, it's also crafting the modules of an application in a way that is expandable, maintainable, easy to read, and so on. And AI is not yet there. It may be as good as people in the future, but it's not obvious. Another thing that is not obvious is, okay, why do we need coding languages? Why in the 1950s nobody has thought about programming a computer in English, in plain English? Because we need a formal language to make formal statements that have no ambiguity. The human language has ambiguity, and the process of translating our thought into code uh, forces us to remove the ambiguity from what we want the machine to do. This is a process that clarifies the ideas, and it's not something we necessarily want to delegate to a machine, because what we want may not be what the machine interprets as our will. So the process of writing code and of structuring modules according to the best practices of software engineering is very important for every data scientist and every machine learning engineer from the very beginning. And second point would probably be do not focus on the latest trends, focus on the basics. I mean, you don't need to learn the latest architecture of diffusion models, because in 3 months' time it will be already obsolete, most likely. I mean, I gave a talk about diffusion models 2 weeks ago, and then Stable Diffusion 3 came out with a new architecture, and my talk became obsolete in 2 weeks' time. So I will give you a new one in Python AI. What does not change is linear algebra, is the basics of calculus, is how to handle tensors, and so on. These stuff are necessary today and most likely will be necessary in 10 years' time. So this is, I think, the second pillar. So good software engineering skills and good mathematics and statistics skills.
Thank you. One last question. So to wrap up, will there be, and can you spoil us some of the key takeaways that you'd like the audience of your upcoming talk to remember from your presentation at Pi4AI?
I think the main lesson will be what simply happens does not happen simply. So we all saw generative AI coming as something out of the blue. It's not true. I mean, the semantics that powers ChatGPT was first discussed in 1957, when the first human being was sent into the space. When the first living creature was sent into the space, Sputnik 2 with like. So the physics behind the diffusion model is more than a century old. The idea of applying such concepts on physics to deep learning was first formalized in 2015, but there are studies even before that. So it takes a lot of time and effort to develop such models, and when they become mainstream, it always happens very quickly, but nobody remembers all the effort and all the studies and all the research that went into creating such technologies, which means that these technologies are very complex. They have huge potential, but they also have huge limitations. I mean, it's like driving a car. So car makers make it very easy for people to understand how to control a car. You have the steering wheel, you have the pedals, and it's very easy to learn. But the physics of an internal combustion engine is very complex. And if you want to truly understand the potential and the limitations of the technology, you have to understand the engineering of the car itself. If you want to understand why it makes sense to transition to electrical vehicles, it's not enough to understand how to control a car and how to drive it. You need to know the engineering behind it. So I think that it's the same with these AI models. If you want to use them, it's very easy because the companies that commercialize them have all the interest in making it easy for people to use them. So there is no need to know how DALL-E works to use it. There is no need to work how GPT works to use ChatGPT and so on. But if you want to learn a little bit more, if you want to be aware of the limits and of the potential of the technology, you need to make one step further and see what happens under the hood. What I would like the audience to take home with my talk is to have some references to understand a little bit better how the technology works under the hood.
Thank you again for your answers and for your time. Really, I'm really hyped to, and we can't wait to hear your talk. Really looking forward to the conference as much as I hope you do. So that we can say we can wrap this up.